speaking of RNS, what do we do if there is a chiral center and we have a double bond? So you can have this happen. You can have a molecule that has chirality centers. So that's a carbon that has 4 different groups attached to it, right? And it can have a double bond that has stereochemistry because of its double bond. Remember that for chirality, we use R and S. Don't get confused between these, R and S. And for double bonds, we use E and Z. So you would still write your R or your S or E and Z as normal, but notice, like I said, they go in parentheses at the front of the name. And you number the position of the chiral center or the double bond that is attached to that R or S distinguishing point. So if you have both, or you have multiple R's or you have multiple E's, etc., you have to number them so we know which corresponds to which position. So for example, in this first molecule, we have a double bond and a chiral center. This is an alcohol. Remember, alcohols get priority, so it's a pentenol. Pentenol. Our alcohol chiral center had an R rotation. So at position 2, which is where the OH is, it had an R rotation. And at position 3, which is where our double bond starts, we see that this has an E configuration where we have opposite groups on opposite sides. And then it's named as normal. This naming situation is the older style. Realistically, you would name this 2R, 3E, pent, 3-ene, to all. Remember to put the 3 with the ene as I suggested. Okay, let's do another example. This question here, I threw all the stops out to give you kind of a really hard example in naming using all of what we've talked about. So this is going to have almost every situation we've talked about in practicing naming. Okay, again, first thing, find longest chain. And in this case, because we have double bonds, we want the longest chain that contains the double bonds. If we go 1, 2, 3, 4, 5, 6, 7, that's one version. Or 1, 2, 3, 4, 5, 6, 7. So each way is 7 carbons long. If I want to pick now which direction I go, I'm going to pick the way that also includes our halide, our chlorine. So this is the longest chain that includes the double bonds in particular, but also our halide. Okay, it's 7 long, as we just saw. So this would be a hept. And we know that there are double bonds present. So it's going to have ene. Now this part is a little tricky. There are 2 double bonds, and just like with any other substituent, if you have 2 of something or more, you have to write your prefix. So this would be a diene. Again, if you had 3 double bonds, it would be a triene, etc. So don't forget those prefixes, even for double bonds. Okay, let's figure out the position of our double bonds. We're going to give them priority over our chlorine. So we're going to start numbering from here. 1, 2, 3, 4, 5, 6, 7. So we have a double bond that starts at position 1 and at position 3. So to finish up our naming of the long chain with the double bond, this will be hept 1, 3, diene. Okay, so that is our main chain. Let's now talk about substituents that are attached to this main chain. We have a chlorine group, and that is at position 6. So let's write 6 chloro. And we also have this 2-carbon long group. So that is an ethyl group at position 5. That's it for any side groups attached to our main chain. So let's write this all together, and then we'll talk about any stereochemistry that can exist in this chain based on how I've drawn it. So remember, we're going to write these alphabetically, so it will be 6 chloro, 5 ethyl, hept, 1, 3 diene. Mouthful already. Okay, now that we've gotten all of our main chain, we've talked about any side groups. Now I want to talk about stereochemistry. I like to do this part second because we're just going to, for the naming, add it to the front, right? Any E's, Z's, or R's, or S's. There are double bonds here, so we have to think about E and Z. And if you notice, there are chiral centers. We'll get to those in a second, but we do also have to think about R and S. First, let's look at our E and Z. We know that there are double bonds. Let's determine if we can have EZ configuration and what it is. Let's look at the first double bond. What does it have attached to it? It has a hydrogen here, a hydrogen here, a hydrogen here, and our chain group here. Notice for this first double bond, we have a situation where we have the same group attached to 1 carbon. And when you have this, remember that you cannot have EZ configuration or cis-trans configuration. It disbars it. So this double bond actually does not have any stereochemistry, does not have an E or Z assignment. Let's look at the other double bond. I'm going to draw my hydrogens in to see where they are. Okay, so this does have a configuration in which we have different groups attached to each carbon. Great. So let's assign its E or Z. I'm going to split it in half. This hydrogen is going to get lower priority. It's pretty straightforward over this group. And same on the side, the big group will get higher priority over the hydrogen. And when we look at our priorities, we see we have opposite. So this is an E configuration. Remember, I have to tell you where the E configuration is. It's on the double bond that starts at number 3. So this would be 3E. Okay, now let's talk about any other chirality or stereochemistry that is available. I'm looking for positions where a carbon has 4 different things attached to it. In this case, it would be this position and this position. These are chiral centers. So we have to assign the chiral centers an R or S configuration. Notice that I've conveniently used some wedging, and that can help you distinguish when you have a chiral center in one of these molecules to help you see spatially what's there. Our hydrogen in both cases, I've also put in the back. It's not shown, but because they're the other group is wedged forward, we can assume the hydrogen is hashed back. So let's assign our priorities. We'll start on this one that has the chlorine. Here our priorities would be 1, 2, 3, which is a clockwise rotation. Clockwise rotation is R, and so on position 6, right here, we have an R rotation. Okay, let's look at this other chiral center. Now we want to give priority here. This group here would get priority. Then this group, oh, I actually did that wrong. It would be, if we want to compare this carbon, and this carbon, it would be this carbon that gets priority, then this group, then this group. And again, to see why these are labeled these priorities, if we look at what our chiral center is attached to, it has a carbon, and a carbon, which is all the same. So we look at what those carbons are attached to. This top carbon is directly attached to a carbon, a hydrogen, and a hydrogen. This carbon right here is directly attached to a carbon, and a hydrogen. And this carbon right here is directly attached to a chlorine, a hydrogen, and a carbon. So the one with priority number 1 has an attachment with the highest atomic number, and then 2 has 1 extra carbon when comparing to 3. Now, if we look at rotation here, this is going to be in the anti-clockwise rotation, which means that it is S. And this is on position number 5. Okay, so now we will put all of our naming together. We're going to have a 3E5 S6R in our parentheses, 6 chloro 5 ethyl hept 1,3 diene. So like I said, this basically has every situation you would see when using our E and Z and R and S configurations. And when you have 2 double bonds, remember we use di here,